Hello, and welcome to the first lesson of Algebra 2. Today, we're going to be learning about our number system. So, numbers are everywhere. There are many different kinds of numbers. There are natural numbers, which are basically counting numbers in a sense, like 1, 2, 3, 4, 5, 6, 7, so on and so forth. There are whole numbers, which are basically natural numbers that include 0. So 0, 1, 2, 3, so on and so forth. Then there are integers. Integers are basically whole numbers with the negatives of the numbers. So -2, -1, 0, 1, 2, 3, and so on and so forth. Then there are rational numbers. Rational numbers are numbers that can be expressed as a fraction with an integer number in the numerator and the denominator. For example, p over q. P would be an integer and q would be an integer. Rational numbers include like decimal places, fractions, and even repeating numbers that are like constantly repeating. This is a rational number because it can be written as a fraction, 1 over 3. And 1 is an integer, and 3 is an integer. So that makes 0.33333 repeating a rational number. Then there are also irrational numbers. A very common example of this is pi. Irrational numbers can be defined as numbers that never terminate or repeat. Then there are real numbers. Real numbers are all numbers excluding imaginary numbers. And imaginary numbers are like the square root of -12, root 5, etc. Numbers that are imaginary have an I in it. I is the square root of -1. In later videos, you guys are going to learn how to simplify roots like this, like root -12, into something like I root 12. It can be even simplified further, but I'm not going to focus that on this video. Okay, time for practice. Pause the video and figure out these questions on your own, and I will be displaying the answer to you in just a couple of seconds. So, what kind of number is 11.01? Since there's a decimal place, we can already rule out natural and whole numbers. And since this terminates is just 11.01, we can also rule out irrational numbers. Therefore, this makes this kind of number rational. So 11.01 is a rational number. Which category does 0 go into, or can go in? Select 2. 0. Is 0 an imaginary number? Does it have an I in it? No. So we can cross that off. Is 0 a counting number? 0 is not a counting number, so it can also be crossed off from natural. And that leaves the remaining 2 whole and integer numbers. Great. Now the numbers are clear, there are some properties of real numbers that are necessary for every student to know. And here they are. So, for example, let A, B, and C be real numbers. So the first property, commutative. An example of this in addition is A plus B equals B plus A. The commutative property is basically the order of the terms or numbers, letters, anything. And that's why A is at the beginning here, but in the right hand of the equal sign, A is at the end. In the multiplication example, AB is equal to BA. It's also an example of commutative property. The associative property is the groupings. So here, parenthesis, A plus B, close parenthesis, plus C equals A plus open parenthesis, B plus C, close parenthesis. The order of the numbers the orders of the letters have not changed, but the parenthesis position has changed, meaning this is an associative property, example. For the multiplication one, it's the same thing. The order of the numbers have not changed, just the position of the parentheses. Next, we have the identity property. This means that, for example, for addition, a plus 0 is equal to itself, which is true because anything plus 0 is equal to itself. And same for the multiplication. A times 1 is itself, a. And that's also true. Let's say half times 1. What does that equal? 1/2. It's the same thing. This is an example of identity property. Then there's also the inverse property, which say the number plus the opposite of itself is equal to 0 for addition. So in this case, a plus negative a is equal to 0, which is true. So if we have 1 plus negative 1, what does that equal? 0. This is an example of an inverse property. Then there's also this one. A for multiplication. A times 1 over a equals 1. This is presuming that a is not 0, because if 0 is in the denominator, then the number is basically undefined because you can't have 0 in the denominator. And so one example of this, let's say 2 times 1/2 is 1, which is true because 2 divided by 2 is 1. Now the next property, I'm sure you're really familiar with this one, the distributive property. This states that a times b plus c is equal to ab plus ac. The a is basically distributed to all the things inside of the parentheses to become ab and ac. Now this property is one that some of you may have seen before, but most of you haven't. And it's called the closure property. It's a really special property, and I'm going to go later in depth of the closure property, but for now, remember that a, b, and c are real numbers. In the addition, a plus b is a real number. So now, real numbers are closed under addition. And same thing for multiplication. ab is a real number. A times b is a real number, meaning real numbers are closed under multiplication. Okay, so the closure property. How does it work? And what is it? So the closure property is a property that relies heavily on our number system. So how does it work? So let's say that we have two whole numbers, 1 and 3. Let's go to addition. 1 plus 3. If 1 plus 3 is a whole number, then whole numbers are closed under addition. So what's 1 plus 3? 4. 4 is a whole number. And so we can assume that now, because of this proof that we have here, if any two whole numbers are added together, then the result will be a whole number. For subtraction, we have 3 minus 1, which is 2, which is a whole number, but we also have 1 minus 3, which is negative 2, and that is not a whole number. So this one example proves that whole numbers are not closed under subtraction. Then we have multiplication. 1 times 3 and 3 times 1 are both the same answer, 3, and which is a whole number. So we can assume that if any two whole numbers are multiplied together, the result will be a whole number. And so whole numbers are closed under multiplication. Division. We have 3 by 1, which is 3, but there's also 1 by 3, which is 0.3 repeating, and that is definitely not a whole number. And so now this example, 1 by 3, proves that whole numbers are not closed under division, as this is not a whole number. And so we can assume that whole numbers are not closed under division. Practice problem time. Match each expression in column A to its property in column B. Feel free to pause the video and figure it out on your own. Okay, here, the first one. We have 2 times 3x plus 7 is equal to 3x plus 7 times 2. Even though it may seem like it's the associative property because the parentheses are like changing because there's no parentheses around the 2, it's really not that, because the groupings are staying the same, just the position of the 2 is changing. It went from the front and now it's in the back. So this property is the commutative property of multiplication. Next, we have x plus y plus 5 equals x plus y plus 5. Here, the order of the numbers are not changing, but the position of the parentheses are, making this one the associative property of multiplication, because the groupings are changing, but the order is not. Here, this one, x plus 0 is equal to x. This is an excellent example of the identity property of addition because x plus 0 is itself x. For the next example, x times 1 is equal to x. This is also another great problem to show the identity property of multiplication because 1 times x is x. Here we have 8 plus negative 8, which is 0. This is an example of the inverse property of addition because we have the number 8, the inverse of it is negative 8. When you add them together, you get 0, which is basically what this property says. And finally, the last one, and everybody's favorite, the distributive property, because 5 is being distributed to both the terms in the parentheses. Next question. Is irrational numbers closed under division? So, short answer, no. And there's clear examples why. So let's take any irrational number. Let's say pi. So we have pi. And what if we divided by pi? What will we get? It would be 1. But 1 is not an irrational number. And so this simple example proves why irrational numbers are not closed under division. Thank you so much for watching and listening to this video. I hope to see you next time.